Alright, so hopefully you watched the video on the Coriolis force. The live link is in the video lectures after part 1. It's also here in the PowerPoint. It just makes this much easier to understand. And once you see this, it makes just much more sense. So, right, the Coriolis effect is just this kind of optical illusion that is caused by the rotation of the Earth underneath objects that are in the air, like wind or airplanes, right? And so, as we'll find, especially when it comes to weather, it depends on if you're in the northern or southern hemisphere. So in the northern hemisphere, things tend to veer to the right, and in the southern hemisphere to the left. And so that's why cyclonic storms, as we'll talk about later, hurricanes, rotate differently north or south of the equator. And again, at the equator, there is no Coriolis effect because, again, you're kind of stationary. So the closer you are to the equator, very little. Um, it's an old myth, by the way. It does not affect how water goes down the drain. So people say that if you're in the southern hemisphere, if you're in Australia, the toilets flush backwards. That's just a myth. It has nothing to do with toilets. So just a refresher, right? If you're imagine here's the North Pole and Santa's taking off on Christmas Eve and he's going to fly to Ecuador on the equator. He's not traveling on the ground, so it looks like a straight line, but as he's going south, right, the Earth is rotating underneath him. And so if he intends to go here to 90 degrees, but because he's actually trying to go straight, it curves. And so he actually ends up at 105 degrees. He's gone a straight line in 3 dimensions, but because the Earth has moved under his feet on a map, it looks that way. So the same thing happens now that we understand this process, right? That when winds move, because winds are, not on the surface, right? They are slightly curved. And so remember how we talked about the pressure gradient? The closer the pressure gradient, or the greater the shift in from low to high air pressure is, in the shorter amount of space, the faster the winds. So the faster the winds, the greater the curve. And this is why if you look at hurricanes, which have some of the fastest, strongest winds of any weather system, they're very tightly curved. So that's one of the first things that affects it. We talked about pressure and Coriolis effect. And the last thing that affects wind speed and direction is friction. So the Earth's surface isn't perfectly smooth, right? There's hills and valleys and buildings and skyscrapers. So those act like friction. If you've ever been in a really, really windy day and you stand behind a building to get out of the wind, right? That wind stops because it goes over the building. That's the friction force. So all wind is slowed in areas of higher friction. And they call that the boundary layer. So it's basically the first half a mile up. After half a mile, there's really not much friction, and everything goes much faster. And that's why, as we'll talk about later in this chapter, upper atmosphere winds can move upwards of 200 to 300 miles an hour with no problem. And the oceans are much smoother than land. If you think about it, right, there's waves, but they're not as big as hills or mountains. And so the boundary layer is actually much, much, much lower over the ocean. So the wind can blow faster right over the top of the ocean. Okay? So all this combines to basically create two types of main weather patterns, cyclones and anticyclones, right? And so you hear the word cyclone, you have a spin. So the difference is a cyclone has a low pressure center. The center of the cyclone is low pressure. I'm going to show you a little map in a moment. And the center of an anticyclone is high pressure, right? Either one of these can create storms. Cyclonic systems, a hurricane is a great example, but so is a winter blizzard, and they can often be very destructive. So here we have an area of low pressure and an area of high pressure. If there was no Coriolis force, right, the winds would rush right here because it goes from high to low, so it would rush in straight in or rush away from the high. But like we said, because the Coriolis effect works, as the winds rush into this low center, they curve. And so this right here is a cyclonic system. The air is rushing in and it spins like a cyclone. The anticyclone, high pressure, wind flows out, so the arms curve away. Okay. Now here's where it gets a little confusing, so just bear with me. This is two-dimensional, right? Let's look at this in 3 dimensions. Let's look at this low pressure in 3 dimensions. In low pressure, all the air is aiming towards that center, right? It's all kind of rushing into the low pressure. So if you were on the surface of the Earth and all that air is rushing, when it hits here in the middle, what's going to happen? It's all going to hit like this and then go up, almost like water, right? So in a cyclonic system, the air pressure above the low pressure gets pushed up by all the air rushing behind it. So all this air rushes in, pushes it up, and then eventually when it gets up here, it just kind of spreads out. The opposite happens in an anticyclonic system. And here you have sinking air. And so the sinking air sinks down to the ground, and when it gets down to the ground, there's high pressure, it just pushes away. So these are basically the opposite of each other. And here is a great example of how this all looks. This right here is a hurricane, and you can see how tight that spiral is of those bands, faster winds. This is also a cyclonic storm, but this is a blizzard that went through Chicago. I believe this was in 2014. So here's the bands. You notice the curve isn't quite as tight, right? It's not quite of a spiral. That's because these winds are only half the speed. Okay, so now that we know how the wind is created, let's talk about the general patterns that we see across the world. And there are basically 4 major air pressure systems that we see. And we're going to go through these in detail. So we'll start off with our first one, the ITCZ, our good old friend. This is that band that kind of follows the equator and the subsolar point, so it moves north in the summer, south in the winter. And here the air is a convergence. The air is converging. So remember that little thing of those systems? What happens when the air converges? Right, it goes up. And so what happens is, right along this band, air converges and goes up into the atmosphere. So the airs are buoyant. Now here's the other thing. It's at the equator. It's very, very warm. There's a lot of water and a lot of tropical plants. There's a lot of moisture. So that air that is rising is warm and moist. And so that gets up into the atmosphere. And when that air cools off, it creates thunderstorms, heavy rain. And this is why, again, we have this huge band right around the ITZ and the equator of those thunderstorms. Okay? Now, that air has so much energy behind it. So much solar energy that drives this whole engine, if you will. That air goes as far as it can go, goes to the very top of the troposphere, right? And that's where weather ends. So this gets way up into the atmosphere. And what happens is, when that air converges and goes up, it goes north or south. And then eventually, it comes back down. I'm going to show you a map of that, but at the equator, the air is going up from the surface. It's getting pushed up into the atmosphere. It cools off, and then it kind of spreads. So, just real quick, think about this. Right, this is what's happening at the ITZZ. The air is rising up. It rains and rains and rains, and then it gets pushed north or south, and eventually it's going to come back down. It's going to do that convergence and form an area of high pressure. And that is our next one. Oh, too far. Subtropical high. So all that air that went up at the ITZZ about 30 degrees north or 30 degrees south begins to sink to the surface and forms what's called the subtropical high. It's called subtropical because it's right near the tropics, which is at 23 degrees north. And what happens is, as this air comes down from high up in the atmosphere, it's lost all its moisture at the equator, all that high equatorial rain in the rainforest, so it's dry air. It comes down, so it's dry. And remember, as air comes down, air pressure squeezes it, so the air heats up. And so what happens is you have this band at 30 degrees north and south where the atmosphere is basically hot and dry. Okay? Wrong way again. Again, that's that adiabatic warming. And so what happens is there's actually a band of deserts around the world at those latitudes. The Sahara Desert is 30 degrees north, so is the Arabian Desert. 30 degrees south, you have the Atacama in Chile and the Namibian Desert in Africa, in main part because the air is just so hot and dry. All right, that's enough for talking about highs and lows. We're going to pause right here because it's time for my dinner, and it's time for you to get up and shake up the sillies and stretch and, just think of all the amazing things you've learned so far, and there's more to go.